All right, we're going to continue talking about our normal distribution. So yesterday we talked about normal distribution. Today we're going to talk about standard normal distribution. They're very, very similar. Standard normal distribution, though, takes the information and standardizes it. So standard normal distributions will always have a mean of 0 and a standard deviation of 1. Here's just a little graph. Again, that peak or that high point will always be 0, and then standard deviations just go by ones. Okay, negative to the left because it's below our mean. When we're dealing with standard normal distributions, we have something called a z-score. So any data point in our on our bell curve is going to be called a z-score. So like I said, z-scores are these standardized values. The absolute value of a z-score is going to be equal to the number of standard deviations away from the mean. So, and then like I said earlier, also the sign is going to tell you whether you're above the mean or you're below the mean. An example, if you have a z-score of negative 2.5, the absolute value is 2.5, which tells you that you're 2.5 standard deviations below the mean. And we use standard normal distributions to put any normal distribution on the same scale so that you can easily compare different types of data. It just standardizes it, so like I said, it's an easy comparison. We do have a formula to convert normal distributions to standard normals. So you have a data value, and to find your z-score, you take your data value minus the mean and divide by the standard deviation. So we'll do an example. If we're at a factory and the weights of a can have a mean weight of 6.5 ounces and a standard deviation of 0.25 ounces, we're going to be asked some questions. Anytime you see this SD, that just stands for standard deviation. So we pick a random can, it weighs 6.9 ounces. We want to know how many standard deviations is this above the mean? Well, asking about standard deviations away from the mean automatically tells us that it's a standard normal distribution, which means that it's a z-score by our definition on the previous page. So we're going to find the z-score for 6.9, our 6.9 ounce can. So we take that x value, our weight of 6.9, minus the mean, which is 6.5, and divide by that standard deviation, which is 0.25. So 0.4 divided by 0.25 gives us a z-score of 1.6, which means that our random can's weight is 1.6 standard deviations above the mean. I want you guys to find, we pull another random can that weighs 6.4 ounces. How many standard deviations is this can below the mean? All right, last example, we have this normally distributed data. We have test scores and two different students' data. So they're in different classes, but we want to compare them. So student A got a score of 63 on their test. The mean was 50 and their standard deviation was 8. Student B scored a 32. Their mean test score was 28 and their standard deviation is 1.8. We want to know who did better compared to their classmates. Again, we have both our normally distributed data, but we want to compare them. Because they have such different values, we have to standardize them, which means we have to find their z-score. So student A, I did their z-score. Test score minus the mean over the standard deviation gives us 1.625. So their test score was 1.625 standard deviations above the mean. Okay, I want you guys to find student B's z-score and then tell me who did better, student A or student B.